artificial intelligence, machine learning, and deep learning. The three popular buzzwords in this new age of technology. Three of these convey the same purpose of building intelligent systems using sophisticated algorithms and techniques, but how do they differ from each other, and how they are similar? In this video, we are going to find out the differences and similarities between each of these technologies. So let's get started. It was 2017, when a computer program named AlphaGo, developed by Google DeepMind, beat the world's most intelligent Go player Lee Sedol in a highly publicized 5-game match. In case you are wondering what is Go, it is a complex board game that has been played in Asia for over 2,500 years, and is considered one of the most difficult games for computers to master, due to its vast number of possible moves. But surprisingly, AlphaGo has beaten Sedol in 4 of the matches played, and that was a historic moment for scientists and researchers in the field of computer science. But how can a computer program be able to beat the world's most intelligent Go players like Lee Sedol? Not just Lee Sedol, but we also may often feel frustrated about failing a chess game against a computer opponent at some point in our lives. In that particular chess game you played, the computer opponent can take quick decisions and can understand how to make the next move before you even think about it. But how a machine can do this kind of crazy thing like human beings? One idea is to hard-code all the rules in the chess game, but it is impossible for such a program to beat the powerful decision-making capabilities of human beings. Here comes an alternative and the most interesting method of doing this. It is to make a computer as intelligent as humans by using algorithms. This is where artificial intelligence comes into the scene. Artificial intelligence is a branch of computer science that deals with the simulation of human intelligence in machines that are programmed to think and act like humans. These intelligent machines can be trained to perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision-making, language translation, and even playing a chess game with you. So with our example, we can say that our computer opponent in the chess game has the intelligence to play the game with us. But, let me ask a question. Is that computer opponent really intelligent? Can it play any other games apart from the chess game more efficiently? Not really. This is where we need to discuss the different types of artificial intelligence. There are mainly 3 types of artificial intelligence, namely, ANI, for Artificial Narrow Intelligence, then, Artificial General Intelligence or AGI, and finally Artificial Superintelligence or ASI. Artificial Narrow Intelligence is also known as weak AI, which is designed to perform a specific task or set of tasks, such as playing chess or recognizing speech. It is not designed to be able to perform a wide range of tasks and is not generally considered to be intelligent in the same way that humans are. Next comes Artificial General Intelligence, which is designed to be able to perform any intellectual task that a human being can. It is considered to be truly intelligent, and is still the subject of much research and development. The other one is more interesting, and some of you may be familiar with it through movies like Terminator. It is known as Artificial Superintelligence. This type of AI refers to the hypothetical future development of intelligent machines that would surpass human intelligence in a wide range of tasks. It is the subject of much speculation and debate among experts, as it is not yet clear what the implications of such a development would be. So that's it with AI, but what about machine learning, and how it is related to artificial intelligence? Think about the same game of chess we have discussed. Imagine, if the computer opponent inside the game can improve with experience from each game with you. In this particular case, the computer program can learn something new in each game and can have a new understanding of playing chess more effectively over time. And this is what machine learning is all about. Machine learning is a subfield of artificial intelligence that involves the use of algorithms to enable a machine to learn from data without being explicitly programmed. It involves the development of algorithms and models that can analyze and make decisions based on data and improve their performance over time. Machine learning also being separated into 4 types. They are supervised, unsupervised, semi-supervised, and reinforcement learning techniques. In supervised learning, the machine learning algorithm is trained on a labeled dataset, where the correct output is provided for each example in the training set. The model is then used to make predictions on new and unseen examples. Think of it like teaching a machine to play chess by providing labeled data of different moves and rules in the chess game. In this case, the machine can identify and learn the different rules and moves in the chess game by analyzing the large dataset of labeled rules. In fact, the simple thing to understand in supervised learning is that, the more the number of data, the more the machine learns. Next comes unsupervised learning. This involves training a model on an unlabeled dataset, and allowing the model to discover patterns and relationships in the data on its own. In the context of the chess game, unsupervised learning could be used to analyze a large dataset of past chess games, without being provided with any information about the moves that were made or the outcomes of the games. In this case, the machine will try to identify the moves, rather than giving it labeled. Semi-supervised learning falls between these two, which uses both labeled and unlabeled data to train a model. It is particularly useful when it is expensive or time-consuming to label a large dataset, as it allows the model to learn from both the labeled and unlabeled data. Finally, there is reinforcement learning, which is one of the most sophisticated types of machine learning. Reinforcement learning is a way for a computer to learn how to do a task by trying different things and getting rewards when it does well. It involves training an agent to make decisions in an environment in order to maximize a reward. The agent learns through trial and error, receiving positive or negative rewards based on its actions. Here, the main goal of the reinforcement learning algorithm is to maximize the rewards and minimize the penalties. So in case of our chess game, reinforcement learning can be used to train the model by providing rewards for each of the good moves it does, and giving penalties for bad moves. In this way, the model will learn how to play chess more effectively. Moreover, through reinforcement learning, the model can even learn over time new and complex moves that were not played by a human. Recall, as we said about AlphaGo. AlphaGo at DeepMind is trained using the modern approach of reinforcement learning. It is known as deep reinforcement learning. In contrast, the difference between artificial intelligence and machine learning is that AI is a broad category of making computers as intelligent as humans, while machine learning is the subfield that makes machines learn from data. Until now, we have discussed about the two technologies and their relation and difference. There is one more important field that must be discussed. It is known as deep learning, which is used more often in all kinds of machine learning tasks today. Back to the example of the chess game, imagine if a machine can learn how to make effective moves by using an artificial neural network, which is inspired by the human brain. We know that all our abilities to understand, think, and make decisions are because of neurons communicating with each other inside our brains. Our brain has billions of neurons, connected to each other, sending signals to make things possible for us, including the fancy intelligence we have. Deep learning is inspired by the brain and is the subfield of machine learning that involves training artificial neural networks on a large dataset. Neural networks are composed of layers of interconnected nodes, and they are able to learn and make intelligent decisions by analyzing and processing large amounts of data. There is no wonder that deep learning and neural networks are here for many years. Older than some of the primitive machine learning algorithms like support vector machines. But recently it got more attention because of the increase in computing power and resources. Training of deep learning algorithms needs a massive amount of computational power and storage. Luckily, right now we have lots of powerful CPUs and GPUs that can process a large amount of data, making this powerful technology literally possible. So until now, we have discussed the three technologies including their relations and differences. Now, let us conclude the video by discussing some of the fields these technologies are used. They are used in a wide variety of fields, from self-driving cars, recommendation systems, chatbots, personal assistants, search engines, and also used for weather forecasting, fraud detection, and many more. With that said, we come to the end of this episode. If you want to know more about these technologies, follow the tutorial on our website. Also, if you like this video, don't forget to leave a like for the YouTube machine learning algorithm. Thanks for watching, and we'll see you in the next one.